So only for today, the class is scheduled at 2 o'clock, and from tomorrow onwards, you'll have the class. Class will start at 6:30. Only for today, we are starting it at 2 to 3 p.m. We scheduled it for 2 to 3 p.m. So let's quickly start. I'm sharing my screen. So let's do a quick recap what we have done in last session. So in last session, we discussed about identifiers in Java. We discussed about identifiers in Java, and then we discussed about data types. We discussed about data types. So what are data types? How many types of data types that we have? Like we have primitive data types, and we have user defined, user defined data types, user defined data types, right? And we have classified these primitive data types, right? So we have classified these primitive data types. So like the primitive data types are of two types. Primitive data types are of two types. One is a Boolean type, one is Boolean type, and another is number type, and another is number type. So number type is again divided into two. They are categorized into two. They are integer type, they are integer type, and they are another is floating point type, floating point type, right? So primitive, when it comes to Boolean, we have only the Boolean data type. When it comes to integer, in integer we have byte, short, int, long, and char. So these are the four integer, integer type data types that we have. When it comes to floating point, we have float and double, float and double. So if you want to represent any values like true or false, you will be using Boolean. If you want to represent any values like true or false, that you'll use Boolean. If you want to represent whole numbers, if you want to represent whole numbers, then you'll use byte, short, int, long, or char. These these integer type. Now, if you want to represent decimal values, if you want to represent decimal values, then we'll use float or double type, float or double type. And eight. There are eight primitive data types, which is known to your Java compiler, which is known to your Java compiler, right? And the user defined is like you, these are like the class type. They are like the class type data types. Okay, for developer purpose. Apart from these eight, if developer defines any data type, then they are user defined, user defined data types. Then they are user defined data types. Example, when I want to represent a car, when I want to represent a car, or when I want to say Anil have a car, Anil have a car, or Anil have a pet, Anil have a pet, something like this. Now, car is another class, and pet is another class, and inside Anil class, inside Anil class, if I want to represent the car or a pet, if I want to represent a car or a pet, anything, any other object, if I want to represent any other object, if I want to represent inside the Anil class, then I have to go for user defined data types. I cannot use eight primitive data types which is given by Java, which eight primitive data types which is given by Java. So apart from these eight, anything for developer convenience, anything for developer convenience, if we define then they are called as user-defined data types. So the user-defined data types are of class type, interface type, enum type, and annotation type. Annotation type. We'll discuss all of this in the upcoming classes. So this is what we have discussed in the last session. Now, so 8 primitive data types, right? So these 8 primitive data types, okay, is linked to one specific size, one specific size, and they'll have a default value, and there is a minimum value and a maximum range for that primitive types. Okay, for example, if I take boolean, if I take boolean, okay, so for boolean there is no size, there is no size. So your JVM or your Java runtime engine, your Java runtime engine will not allocate memory for Boolean data type values. Boolean data type values. So basically, Boolean will have only two options, which is either true or false. True or false. These are logical values. These are logical values. So for Boolean, there is no size defined. There is no size defined. Only you have the possible values is true or false. True or false. And in case if you define a Boolean type, if you define a Boolean type in your program, and if you didn't give any value, if you didn't give any value, by default, your JVM will take false as the default value. False as the default value. Okay. So when I define a class called Anil, when I define a class called Anil, okay, so I'm defining a variable, okay, is valid, something like this. Is it valid? When I'm defining a variable called is valid, and I'm saying that this is of Boolean type and this is of Boolean type. So now is valid is a variable. Is valid is a name of the variable of type Boolean. But I'm not giving any value here. I'm not giving any value here. If I don't provide any value now, if I don't provide any value now for is valid, by default, your JVM will assign a value called false, default value called false. If you are not defining any value, JVM will assign the value for it by default. If you assign some value, if you assign some value, then your JVM will take whatever the value that you have given. If you don't give any values, by default, it will assign false value for Boolean. Okay. Similarly, if I take byte, if I take byte, so if you remember a byte, char, long and int, all these are required for you to represent the whole numbers. These are required for to represent whole numbers. So if I take byte, so when I define a byte variable or a byte type variable, when I define a byte type variable, so basically it takes 1 byte of memory. It takes 1 byte of memory, and the default value for byte is 0. The default value for byte is 0. And for when I take whole numbers, there is something like range. There is something called range. So the range is something like this. It is defined. So there is a formula to calculate the range. What is that is? What is that is? Okay, 2 power n minus 1 minus 2 power n minus 1 to, okay, 2 power n minus 1 minus 1, where n is the where n is the number of number of bits, number of bits. When I take byte, Okay, so when I take a byte type variable, the memory that Java will allocate for that variable is 1 byte. So 1 byte is equal to 8 bits. 1 byte is equal to 8 bits, right? So now as per this formula, what is the minimum value? What is the minimum value that I can store inside a byte type variable is minus 2 power 8 minus 1 to 2 power 8 minus 1 minus 1. So as per this, if you calculate, it will come minus 2 power 7 to minus 2 power 7 to 2 power 7 minus 1. So 2 power 7 means 2 in 2 into 2 into 2 into 2 into 2 7 times. Multiply that into 7 times. 3, 4, 5, 6, 7. So 2 fours are 8. Sorry, 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 64, 64 twos are 128, right? 128. So the minimum value what you can store inside a byte is, okay, the min value is minus 128, minus 128. What is the maximum value that you can store? What is the maximum value that you can store? So the maximum value is 2 power 7 minus 1. 2 power 7 means 128 minus 1, which means till 127. So the max value that I can store is 127. So the number range between minus 128 to 127, I can store inside a byte data type variable, a byte data type variable. For example, if I take, if I define a class demo, if I define a class demo, and when I'm saying byte x is equal to byte x is equal to, x is a variable. What is a variable? We'll define it. We will discuss that. Now x is equal to, what is the value this x can hold is the number range between minus 128 to 127. Within this number range, anything that you can store inside this x variable, I can store minus 126, right? I can store minus 100, I can store minus 99, I can store 0, I can store, 1, I can store 10, 22, 25, 95, 100, 110, 124, and 126 till 127. Till 127. If I give 128, if I give 128, now the range, if you see, 128 is allowed only with the negative value, within the negative value. If you give 128 a positive 128 value here, the range what it can store is up to 127, up to 127. Now if I store, 128, if I store 128, it cannot store inside byte. If I give byte x equal to 128, your compiler will immediately will raise a compile time error. Compile time error. Reason is it can store within the range of minus 128 to 127 value. Only this whole number range can be stored inside byte. Okay. Now you will get, okay, out of range. The byte is has went for out of range. You have to go for higher level. You have to go for the higher level. So what is the next is short. Next is short. So short takes 2 bytes of memory. Short takes 2 bytes of memory, right? So 2 bytes means 2 into 8, which is 16 bits, right? 16 bits. So as per the formula, 2 power n minus 1 minus 2 power n minus 1 to 2 power n minus 1 minus 1. As per this formula, it is 2 power 16 minus 1 to 2 power 16 minus 1 minus 1. So which is like minus 2 power 15 to, okay, 2 power 15 minus 1. So this is the max range of short. This is the max range of short. So this is the minimum value it can store, and this is the maximum value it can store. It can store. Similarly, for int it will take 4 bytes. Int it will take 4 bytes. 4 into 8, which is 4 8s are 32 bits, right? 32 bits. So as per the formula, it is minus 2 power 31. So 32 means minus 1 I am taking off, 2 power 31 minus 1. Long will, when I define a long variable, then a long type variable, if I define in my program, long will take, or long will occupy 8 bytes inside memory. 8 bytes inside memory. So 8 8s are 64. So why I'm calculating with 8? So 1 byte equal to 8 bits. So 8 bytes, 8 into 8, 64 bits. 64 bits. As per the formula, it is minus 2 power 63 to okay, 2 power 63 minus 1. Okay. So this is how we calculate. This is how we calculate the range for the numeric type values. The numeric type values. Now there is one more numeric type that we have. So which falls under integer type data, which is that the char type. So we have byte, short, int, long, and char. So characters. Char will store the characters. So whatever the characters that you have, one single character only it can store. One single character only it can store. So for example, if I want to store A, okay, if I want to store B, if I want to store C, or if I want to store D, why this A, B, C, D? I'm saying only one single character. Only one single character. Let's say you designed an application. Let's say you designed an application. So which is like which is like you have a multiple choice questions there where you capture the answer either A, B, C, D. Think that you designed an application, and in that application there are some questions that you will be giving, like a question paper. Okay, one question paper kind of application. So possibly you have multiple choice questions there where you write up, where you select where you ask them to select the question or select the answer there. So now they'll not write the essays there. What they'll say, they'll choose a either first option, second option, third option, or the fourth option. So what is the value that you wanted to capture? It's only one single character. It is one single character. So if you want to capture that kind of characters, then you will go for char type variables. Char type variables. Now if you take, these are all characters. These are not all, these will not have any values, right? These will not have any values, but this will fall under integer type. This will fall under integer type. So the reason why it fall under integer type is basically the char will capture only one single character, that is from your keyboard. The input will come from your keyboard, right? So how do I give an option, right? It is A or B, C, D, anything that is coming as an input as an option to me. Okay, either it can be from your mouse or from your keyboard. So if you take a char type, if you take a char type in C, if you go for a C programming, you go for C programming. C program is written in ASCII standard. It is written in ASCII standards. It is written in ASCII standards. Your keyboards are designed in ASCII. Keyboards are designed in ASCII. So the range of keyboard is, maximum number of keys that you can have in a keyboard is 127. 127. 7. The maximum number of keys that you have in your keyboard is 127. So using this 27 characters only, using these 27 characters only, you have to write your program. You have to write your program in C. But when it comes to Java, when it comes to Java, Java is written in universal code, which is called Unicode language. It's a Unicode programming language. Unicode programming language. So this we have discussed already. So if you want to print a pi, or if I want to print a rupee symbol, you can't do that in your C program. Here you don't do, you cannot do that. But in Java, you can do that. In Java, you can do that. So it covers both the ASCII standards and it will add some additional characters there. It will add some additional characters. What are those? What are those is, so in Java, the char range starts from, in Java, the char range starts from 0. It will start from 0. So 0 means this is a ASCII representation. 0 means it's a ASCII representation. The same thing if you want to represent in Unicode, that will be /u. /u here indicates, \u indicates it's a Unicode, and 4 zeros you will be having. What is this 4 zeros? We will discuss in the literals concept. We'll discuss that in the literals concept. So /u 0000 is the value that you represent for 0 inside in Unicode format. In Unicode format. So the char range start from 0, and the maximum number of characters that your Java program can support, is 2 to the power of 16 minus 1. Okay, so there is a different formula for calculating the char range. There is a different formula that is used to calculate the char range. Okay, so always for char, the minimum value is 0 and the maximum value is 2 to the power of 16 minus 1. So which means 2 to the power of 16 means, so it takes 2 bytes. Char occupies 2 bytes of memory, 2 into 8 bits, right? 2 into 8 bits, which means your char occupies 2 bytes of memory. 2 bytes of memory. Okay. So only there is exceptional formula for char, because Java is defined in Unicode programming language. Unicode programming language. So which means maximum of, which means the maximum of around 2 to the power of 16. If you calculate, it will come around 65,000, 0 to 65,535, I guess. It will be 36. 65,536 will be the value. Minus 1 we have to do. Minus 1 we have to do. So these many characters, or these many characters that you can represent in your Java programming language. Okay. So for example, if I want to represent A, okay, A will have one specific number. A will have some specific number. One number is assigned to this A value, which is like 40 or 41 or 42 or something like this internally. Okay. So when I'm trying to give A, for example, when I'm trying to give A, so internally your Java programming, or your your compiler will replace this A with some value. A with some value. Okay. It'll save A with some value like 40, 41 or 42, something like this. Okay. So that you can find it from the ASCII table. That you can find it from the ASCII table or Unicode table. So if I click on ASCII table, you see that for space, there is one value. Okay. For each character, there is a number defined. There is some number defined. Similarly, if I'm trying to print a 0 internally, it will represent 48 number. Okay, your when you give 0, so the number that is assigned for 0 internally by your compiler is 48. Okay, similarly, if I want to print a, so 65. Okay, 65 is the number. 65 is the number. So when I'm giving a, so a will be replaced with the number called 65. So which means again the decimal value internally it will allot. It will allot. Okay, so each character, you see that each character, all these characters that you see it on your keyboard, right? All these are the key characters that you see it on your keyboard. So based on these characters only, your keyboard is designed. But when it comes to Unicode, okay, Unicode, you see that this is represented with /u. 0 will be represent something like this. Okay, /u triple zero, 1, 2, something like this. So in the Unicode, if I want to represent something called the special characters, okay, 0021, 0021. How to do a conversion of this? How to do a conversion of this? We'll see it later. But for each character, there is a Unicode value. There is a Unicode value. So if I want to print this symbol, right? You see this symbol, I can't print it in ASCII. I don't have such kind of symbols, right? But if you see here, if I want to print this symbol or R at the rate or plus underscore minus, power 2, power cube, right? Pi symbol, 1 by 4, 1 by 2, 3 by 4. So any of these characters I can't print in ASCII, but it is possible with the help of Unicode character set. Unicode character set, right? So, so the maximum number you see here, these are all 235. These are all special characters. Whatever the numbers that you see it here, this is the range. If you go till end, all these you can represent. All these you can represent in your Java programming language based on the need. Based on the need. So the range of your Unicode is greater than ASCII. Greater than ASCII. That's the reason. That's the reason char will occupy 2 bytes of memory. That's the reason char will occupy 2 bytes of memory. Okay. So the range is 0 to 65,535. Okay. ASCII range is 0 to 127, which can fit in 1 byte of memory. 1 byte of memory. So in C programming, okay, char will take in C programming, char type of data will take only 1 byte in memory. One will occupy 1 byte inside the memory, but in Java, it will occupy 2 bytes in memory. The reason is it is designed in Unicode format. It is designed in Unicode programming format. Okay. So that's about the size. Similarly, float also you have. Float also you have. Float will have float. If I define float, so the minimum value will be 1.4 e power minus 45, and the maximum value will be 3.440 e power e38. E is equal to 10 to the power of 38. E here indicates 10. 10 to the power of 38, something like this. 10 to the power of minus 45, right? So float and double are like infinite values. If you want to define that you can define with the help of float and double. Float and double. But float and double, if you wanted to do any scientific calculations, right? Any precise calculations if you wanted to do, then you will go for So I'll write it in a proper way now. So Boolean, so just a minute. Type, the size in bytes or in bits. Default value, the minimum value and maximum value. If I take byte, so it occupies one byte of memory. So which is like 8 bits, which is like 8 bits. The default is 0. Default is 0. Minimum is minus 128. Maximum is 127. So similarly, char if I take. So if I take char will occupy 2 bytes. So which means 16 bits. 16 bits. So the default value for char is also starting from it. Char also will start from 0. So the default value for char is 0. Okay. So the maximum, what is the minimum value? 0. The minimum value is 0. Maximum value is 65,535. Maximum value is 65,535. Short. Okay. Short also will occupy 2 bytes. Short also will occupy 2 bytes. So which means 16 bits. 16 bits. So this formula, this will be a huge values. We can't calculate. So it will be like 32,000 something, 32,768. So the formula, you use the formula, it will come minus value. This is minus value, minus 32,768. So the sorry, this is the default value, right? The default value is 0. For short also the default value is 0. The minimum value is minus 32,768. The maximum value 32,767. Similarly, int will take 4 bytes. So it is 32 bits. Default value is 0. Default value is 0. Minus 2 power 31 is the value. So it will be very huge number, something like 21, 21, 47, 48, some range it will be there. You can calculate that. So that is minus 22 power 31 minus 1. Similarly, long. So long will take 8. 8 means 64 bits. So default value is 0. Default value is 0. So that is minus 2 power 63 is the minimum value. This is minus 2 power 63 minus 1. Okay. So float. For float will occupy 4 bytes of memory. Float will occupy 4 bytes of memory, which means 32 bits. And the default value for float is 0.0. Default value for float is 0.0. These are represented in the decimal format, point values, 0.0. And defining these ranges are very difficult. So that is like 1.4 e power minus 35. Sorry, e power minus 45, I guess. This is the minimum value, and the maximum value is 3.40 e power 30. So e into 38. Okay, 10 into 38 times. That's a maximum number of maximum value that you can store inside float. So if you want to have double precision, if you want to have a double precision, then you go for a double value. So double will occupy 8 bytes of memory and it takes 64 bits, and the default value for double is also 0.0. Okay, so that is like double the type of float value, double than float. So if I take, it is like 4.9 e power minus 324. and the maximum value will be something like 1.7979 e power 308. So which is like very huge number. This is like infinite number definition. Okay, and if I have now all the sizes we discussed for primitive, what if there is a user defined data type? What there is a user defined data type? So user defined data types are called as reference data types. User defined data types are also called as reference data types. So any reference data type, any user defined or reference will occupy 8 8 bytes of memory, which is 64 bits, and the default value for any reference user defined data type is null. Null is the default value for any user defined data types. For example, if I define a car object inside Anil object, or a pet object, or a pen object, or any object, and if I don't give any value to that object, by default the value will be null. By default the value will be null, and these are standard and fixed, and there is no min number and max number. Okay, there is no min number or max number for the reference type. For class types, there is no range. For class types, there is no range. Okay, so this is about the ranges of the data types. The ranges of the data types. Any questions on this? Any questions on this? These will help you a lot. These will help you. This table will help you a lot going forward. So this is one rule for the data type. You have to remember the ranges and the default values. So if you just remember the type and the size and the default value, 90%, 90% you are successful in learning Java. So variables concept, you know that if there is an object and if you want to represent the properties of an object, you need variables, right? You need variables. So if you remember this, then you will be learning like 50% of Java. You know 50% of Java basics. Based on this table only, the whole next levels will be dependent. Next levels will be dependent. Any questions on this? Any questions on this? So assuming there are no questions, in case if you have any queries, you can ask me. Okay, that's fine. Now, so now we'll discuss about the new topic called variables. We have actually reached the concept of till variables. You know that variables are required to represent the properties of an object, the properties of an object, right? So for example, if I take car as an object, if I take car as an object to represent the properties of a car object, you need variables. So for example, if I want to represent the name of the car, model of the car, right? Model of the car, price of the car, okay? Engine type, engine type, right? So uh, fuel type, okay? Fuel type, and you can have n number of. right? You can have n number of properties for a object. So to represent these properties of an object, you need variables. You need variables. So variables are required for you to represent the properties of an object. Properties of an object. What does this variables actually store? What does this variables actually store? For example, when I define car as an object, when I define a car as an object, name is a variable, name is a variable, model is a variable, price is a variable, engine type is a variable, right? Fuel is a variable, fuel type is a variable. All these are the variables. All these are the variables. Now, what is the value? What is the value? Okay, that will be captured inside this name is defined by the data type. So when I say string, when I say string, what is string we'll discuss. So string is a group of characters. So when I say name, it's of string type. It's of this variable is of string type. When I say model, okay, when I say model, model is again characters. It's of string type, string model. So when I say price, price is of numbers. So price can have some decimal values. So I can go for double or float. It's up to you. Float or double based on the value that you are capturing. Right? Is automatic a question? Is automatic? Is it an automatic? Yes or no? So is it like true or false? Yes or no is like true or false, which is like Boolean. So now you know that, okay, all these properties are captured as variables. Okay, engine type can be petrol or diesel. Petrol, sorry, fuel type can be petrol or diesel. That is also of string type. That is also of string type. Engine type can be like 1.2 liter engine, something like this. So which is of float type. I'm taking it as a float type. So now you see double, float, boolean, string, or any of these are like the data types. These are the data types which is required for you to explain the developer that, or explain your Java compiler that inside name we are capturing this type of data. Inside this name we are capturing string type data. So inside price we are capturing double size data. So you are explaining the compiler that, hey compiler, there is a property called price for my object, and in the price property I am capturing the double size or double value. I'm capturing the double type data, right? Double type data. For example, if we take one more example, maybe if I take Anil as an example, if I take Anil as an example, so class Anil have a name, Anil have a age, Anil have salary, Anil have email ID, Anil have phone number, Aadhaar number, right? All these are the variables. All these are the variables. So now for name, what is the type of value that I am saving inside name? What is the type of value that I'm saving inside name? I am telling that with the help of a data type called string. So inside name, I am capturing a group of characters which is called string. I am capturing string type data in the name variable. I'm capturing the string type data in the name variable. So age will be of number. So I am taking int here. That's up to you, short or byte, whatever you wanted to take, you can take it. So for now I'm taking an integer number. So which says age is a property, and we are capturing int type data inside age variable. Similarly, salary will have floating value. Salary will have some float values. So I'm taking float salary. So There is a, for Anil object, there is a property called salary. And in this salary variable, we are capturing float type data. This is how you are explaining it to your compiler. Okay. Similarly, email ID. If I take email ID, so email ID will have a group of again characters, a group of it's about a group of characters. So which is like a string. So there is a property called email ID for object Anil, and I'm capturing string type data inside that email ID, right? Phone number. So phone number is like a very big number. It's a very big number. For example, if you take phone number will be like 9933 11 22 something like this. Then you look at the range of this number. So this is a huge range. It's not within the range of the term. It will have phone number will have 10 numbers at least, right? So it cannot fit in integer. So I'll take long here. I'll take long here. So long phone number. So phone number is a variable, or a phone number is a property of Anil, and we are storing very long data inside phone number. Aadhaar number. Similarly, Aadhaar number, which is a 16-digit number. I'll go for long. Simple. So now using data types, you are explaining what type of data that you are storing inside a property. What type of data that you are storing inside a property. Here I'm storing the string type data inside name. Okay, here int type data I'm storing inside age. Float type data I'm storing inside salary. Okay, string type data I'm storing inside email ID. Long type data that I'm storing inside phone number, and long type data that I'm storing inside Aadhaar number. So this is how you are explaining. Okay, with the help of data types, you are explaining your program to the compiler and to the interpreter. Okay, so this is how your program will be understood by the computer. Okay, so you are explaining it to the, you are explaining this program to the Java compiler. Java compiler will validate these rules. Okay, when I say int, okay, what is the number range that he is storing? What is the number range he is storing? When I say 32, whether it is in the range of 32? Yes, it is in the range of 32. This is valid. Go ahead. Okay, when I say name, when I say name, name is Anil. Okay, whether it is in the range, or whether he has defined the name correctly? Yes, correct, valid. Go ahead. Okay, whether here spelling he has given correct or not. All these rules will validate by your Java compiler. Java compiler, right? So now, simple to say, name is just a place. Name is just a place, right? It's a place inside the memory location. The memory location. How these properties your Java compiler or Java interpreter will represent inside memory, right? So inside memory, so now we defined a name variable, right? A age variable, and email, phone number, Aadhaar number, something like this. How these are represented inside memory? Inside memory, how these are represented? So inside a program, when we write all this, for example, this as a string, this as int, this as again string, and this is long, and this is long. So think this is the memory inside your computer. This is the memory inside your computer. Okay, so now when I say int, so int will take how much amount of memory? Int will take how much amount of memory? It will take 4 bytes, right? So it will block 4 bytes of memory inside. Think this is your memory. Memory is nothing but this is your RAM. Okay, not your disk. It's not a disk. This is your RAM. Always the programs will execute on the RAM space. It'll always the programs will get executed in the RAM, not in the disk. Never on the disk. Okay. Whenever we represent, or whenever we say memory, that's the RAM size. That's the RAM size. So think this is your RAM, or this is your memory. So it will, when I say int, Okay, 4 bytes of memory, right? 4 bytes of memory block will be created inside your RAM, inside your RAM. And the name for this, the name for this memory block is, what is that we define in the program? Age is the name of the memory block. Age is the age is the name of that memory block. So inside this memory block, when I say age equal to 32, I'm assigning some value to it. So that 32 will be stored inside this age value, age memory location. Okay. So similarly, when I take long, long means it will occupy 8 bytes. It will occupy 8 bytes of memory. So for example, you have 8 GB of RAM. If you have 8 GB of RAM, so within this 8 GB, we'll discuss about this memory allocation. But think that within that 8 GB for now, it occupies 4 bytes for each and 8 bytes for now phone number. The name of the variable is phone number. And inside this, if you give any value, double nine, 22, 33, 44, something like this, that value will be stored here. So when I'm trying to print, when I'm trying to print age, when I try to print age, for example, in Java. So when I try to print age, your runtime engine, Java runtime engine knows that, okay, age is the name of the memory location. Age is the name of the memory location inside RAM. So your JVM will go and connect to this memory, and it will look for what is the value that is inside this age. What is the value that is inside this age? So here you have 32. So you get 32 as an output. You get 32 as an output. When I say print phone number, when I say print phone number, now your JVM will go and look, or will look for the reference called phone number. Okay, if it is fine, then what is the value inside this? 99, 33, 44. So this it will print. This it will print. Okay. So simple to say, variables are required for you to represent the properties of an property of an object, right? So variables are variables are required to represent properties of an object, properties of an object. Now, so when it comes to the actual definitions, like variables are the names of memory location, the of names of memory locations in computer memory. Computer memory. So which is computer memory means RAM. And so what about the value inside this? What about the value? What about the value inside this? Okay, is it fixed once it enters the value? When I say age equal to 32, when I say age equal to 32, so this value is fixed here? No, nothing like that. This value can change at any point of time in the program. The value can change at any point of time in the program. So that's the reason it is called as variable. So which means can change. The meaning of variable can change at any moment. At any moment. Variable means it can change at any moment. So in the program, the value inside a variable can be modified at any point of time. Any point of time. Okay. So variables are required for you to represent the properties of an object, and these are like the names of the memory location inside your computer memory, inside your computer memory. And the values inside that variable can modify at any point of time during the program. And now one important, okay, the 4 bytes of memory or 8 bytes of memory, who will allot this 8 bytes of memory or 4 bytes of memory? Is it by your computer, or is it by your compiler, or is it by your interpreter, right? So whether who will assign the who will allot these 4 bytes of memory or 8 bytes of memory, 8 bytes of memory to the data type. Okay, so to remember, compiler will only validate the rules, will only validate the rules. So compiler duty is to validate all these rules, like I have within the range or not, whether he has defined the structure properly or not, is there a grammatical mistakes or not. Once this is done, okay, it converts the program to a to a intermediate language, which is called bytecode. So, okay, now during the runtime, during the runtime, your JVM will allot. Okay, JVM is your interpreter will read the code, and then in the memory the 4 bytes or 8 bytes will be allocated by the interpreter. Your JVM will do that, not by your compiler. Okay, you're always the interpreter allocates the memory for the variables at runtime. Memory will be allocated at the runtime, not at the compile time, not at the compile time. Okay, so variables are required for representing the properties of an object. Variables are the names of the memory locations in the computer memory, and the variables can be modified at any point of time during the program. And fourth is, the memory for the variable is allotted during the runtime of a program, not at the compile time, not at the compile time. The duty of compiler is to validate, okay, whether the values are within the range or not, values are within this range table or not, right? So your compiler will validate only these ranges and all. It will not allot the memory. It will not allot the memory. Your JVM will allot the memory for the variable. Okay. So there are, so any questions on this? I've just given an introduction to this variables. Any questions onto this? Any questions? Any questions? Any questions on variables or data types or any other questions that you have? Any questions? Any questions on the variables? Assuming there are no questions on the variable topic, or maybe on the data types topic, so we'll wind up the session today here, and we'll meet again in tomorrow's session. So do remember that from tomorrow onwards the class will be from 6:30 onwards, only for today. So it is being shifted to 2 to 3 o'clock. So any questions that you guys have, please reach out me, and I'll provide these notes, the data types notes and the variables notes today, and you can go through that notes. And if you have any questions, you can reach out me.